Good morning, my dear students. I hope you all are fine. Today we are going to discuss the new topic, spherical lenses. First of all, what is lens? What is lens? A lens is a transparent medium having a spherical surface. Okay, a lens is a transparent medium having a spherical surfaces. What is a transparent medium? The transparent medium means if the light is passing through an object, that type of object is called transparent object or transparent medium. Here, lens is a transparent medium having a spherical surface. Okay, having spherical surface. There are two types of lenses. One is convex lens, and second one is concave lens. That is, there are two types of spherical lenses. One is convex lens and second one is concave lens. Okay, what is lens? Lens is a transparent medium having spherical surface, and there are two types of spherical lenses. One is convex lens and second one is concave lens. Okay, I am showing you the concave and a convex lens. Here, this is a convex lens. Okay, this is a convex lens having spherical surface and it is a transparent medium. Okay, this type lens is called convex lens, like this. Okay, the center part of this convex lens is thick part. The center of this convex lens is very thick, and it is a transparent medium and having spherical surface. Why it is called spherical surface? Here spherical surface because it is the part of an imaginary sphere. Okay, it consists of two spherical surfaces. That means here there are two imaginary spheres. One is this and second one is this. Okay, this is the shape of a convex lens. And the second one is concave lens. Okay, this is a concave lens. Okay, this is a concave lens. It contains or it consists of two spherical surfaces, and the center of this lens, is thinner. Okay, very thin part. Its center is thinner. Okay, that means the shape of a concave lens is like this. Okay, concave lens is like this. That is, it have two spherical surfaces and it is a imaginary. It is a part of a imaginary sphere. Okay, that means a concave lens also consists of two spherical surfaces. Okay, these are the two types of spherical lenses. One is convex lens and a concave lens. Okay, next we are going to discuss some terms related to this lenses. Okay, spherical lenses. Okay, listen here. We have two types of lenses. One is, this is convex lens, and this is concave lens. Okay, next we are going to discuss some terms related to this spherical lenses. The first term, optic center. Optic center. Okay, optic center. The optic center means it is the midpoint of a lens is called optic center. That is, the midpoint of a lens is called optic center. That is, this is a lens. This is a lens and its midpoint is called optic center. Okay, and it is represented as P. This is the optic center of convex lens, and similarly here this midpoint of this lens is called optic center. Okay, that is the first term, optic center. The optic center is the midpoint of a lens is called optic center. Okay, optic center, and it is represented as P. Okay, P. Clear? Okay. Next one, center of curvature. Center of curvature. Center of curvature. Okay, listen here. Center of curvature means we have in a lens, it consists of two imaginary sphere, or the spherical surface is a part of a imaginary surface, imaginary sphere. Okay, that is, here this is the imaginary sphere of this part, and this is the imaginary sphere of other surface. Okay, and the center of this imaginary sphere is called center of curvature. A lens is consist of two imaginary sphere, and the center of that imaginary sphere is called center of curvature. Okay, that is, a lens consists of two center of curvature. A lens consists of two center of curvature, and it is represented as C. Okay, C. Okay, that is, the center of curvature means a lens have two spherical surface as part of lens. The center of curvature C is the imaginary sphere of which the side of the lens are parts. Okay, that is, the center of the imaginary sphere is called center of curvature. Center of curvature, and it is represented as C. Okay, first one is optic center, and it represented as P, and the second one is center of curvature, represented as optic center P and the center of curvature C. And the third term related to lens is principal axis. Principal axis. A principal axis is the imaginary straight line. Imaginary straight line passes through the optic center, joining the two center of curvature. Okay, joining the two center of curvature. That is, here principal axis is a straight line passing through the optic center, joining these two center of curvature. This straight line is called what? Principal axis. Okay, principal axis. Similarly here this is the center of curvature of this lens, and here joining these two center of curvature through optic center, that straight line is called what? Principal axis. Okay, principal axis. These are the three important terms related to what? Spherical lenses. Then next we are going to discuss another session, that is another term related to this lens, that is principal focus. What is that? Principal focus. Principal focus. Okay, listen. For explaining this principal focus, we consider first we are going to discuss the principal focus of convex lens. Okay, convex lens. Here let us consider a convex lens. A convex lens of midpoint is called optic center, and this is the center of curvature of this lens, and this is the principal axis of this lens. Okay, now here we are passing some light beams. There is here we are passing some light beams parallel to this principal axis. Okay, the light beams are passing parallel to this principal axis. That time, here we have, in the case of a spherical lenses, the refraction is take place. We already studied in the case of mirrors, the reflection is take place. Here, in the case of spherical lenses, refraction is take place. That is, when a light is passing to this lens, that time the refraction will take place. Okay, that is, here the light is deviating and it converges, right, point. Okay, that is, here when a light beam is passing, a light rays are passing parallel to the principal axis, and the refractor rays are converges to a point. The refractor rays are converges to a point in a principal axis. That point is called principal focus of a convex lens. I repeat, when a light beams or the light rays are passing parallel to the principal axis, and the refractor rays are converges to a point that in principal axis. Okay, that in principal axis. That point is called principal focus. Clear? This principal focus is represented as capital letter P. Okay, capital letter P. Clear? Okay. And the next one is, here the light rays, in the case of a convex lens, the light rays, these parallel light rays are refracted and it converges. Okay, converges. Okay, that is, in the case of convex lens, the light beams are converged. Okay, converged. Clear? Okay. The next one is the principal focus of concave lens. Concave lens. For that, consider a concave lens. concave lens of center P, that is optic center, and this is the principal axis, and this is C, center of curvature. Center of curvature. If the light rays are passing parallel to the principal axis, here the refraction is take place. But in the case of concave lens, the refractor rays are diverged. The refractor rays are diverged. That means this refractor rays not converged at this principal axis. That means here the principal focus is not formed. Okay, and this condition here we are considering a imaginary principal focus. How? I am extending backward to this ray, and this joining point is considered as principal focus of concave lens. Concave lens. Okay, that is here the principal focus is virtual. Here in the case of concave lens, the principal focus is a virtual focus. Okay, that is in the case of convex lens, the principal focus is real. That not imaginary focus, that is real focus. But in the case of concave lens, the principal focus is virtual. That means here the principal focus is imaginary focus. Okay, imaginary focus. Clear? This is the principal focus of concave and convex lens. Concave and convex lens. Okay, the next term related to lens is focal length. Focal length. Focal length. It is represented as small letter f. Okay, we have what is principal focus. For example, in the case of convex lens, here this is f, that is the principal focus. Here also f is here. Clear? Okay, the distance between this optic center and principal focus is called focal length. Listen, the distance between the optic center and principal focus, optic center and principal focus is called focal length. That represents as small letter f. Clear? And here the distance to the center of curvature is called radius of curvature. Radius of curvature. And the focal length f equal to, therefore the focal length f equal to here r by 2. The focal length f equal to r by 2. Clear? Okay, that is here the distance between the optic center and principal focus is called focal length, and it is represented as small letter f. And we have the distance to the center of curvature, that is optic center to the center of curvature, is called radius of curvature, and it is represented as capital letter R. Therefore, the focal length f equal to what? R by 2. R by 2, that is half of the radius of curvature we get the focus. Okay. For example, if the radius of curvature radius of curvature, if the radius of curvature is 20 centimeter, then what is the focal length? F is equal to R by 2, that is 20 by 2, that is 10 centimeter. Okay, that is half of the radius of curvature we get the focal length. At that distance the principal focus is formed. Clear? Okay, this is focal length. Is it clear? Okay, these are the terms related to what? Spherical lenses. Okay, there are two types of spherical lenses, concave lens and a convex lens, and the terms related to these spherical lenses are optic center, center of curvature, and principal axis, principal focus, focal length, radius of curvature. These are the terms related to spherical lenses. Okay, I hope you all are understand this session. Clear? Okay, thank you.